Okay, so here's another one. They want to find out what's the shape of the molecule and then what's the polarity based on the symmetry of the structures. The second problem is SO3. So SO3, S is right here, which is on the sixth column. So the way that I kind of figure it out how the bond is being formed, oxygen has a 6 valence shell electrons because oxygen is right there too. And so this one is essentially need 2 electrons forming a bond, and that's a good starting point. And by doing so, they develop negative charges. So the 2 electron is what they are looking for to satisfy the octal as a neighboring one. And as far as sulfur is concerned, sulfur is 6 electrons here. These 6 electrons are going to be break it into 2 electrons to form the bonds like this. And once you use up the 6 electrons, you have nothing. So no electron to 4 lone pairs, right? Just looks like this, lone pairs. So therefore, the first structure that you will draw is a sulfur with essentially those 6 electrons are essentially paired up with an oxygen. So let me make it clear. Oxygen is right there, and they have their own 6 electrons. Okay, so this is a little unconventional, but you might want to do to figure out the Lewis structure this way, and that's also kind of the straightforward and faster way to figure this one out. So once you have that, this structure is shown up as can be shown as like this with these structures. And as I discussed in the previous one, this is a -1 formal charges, and overall there is no formal charges. That means 3 formal charges in the middle. You can calculate it using the formula to find out this has a formal charges of 3. And once you do that, this formal charge can be minimized by forming a double bond here, by forming a double bond here, by forming a double bond here. Right? As we discussed before, this one can go back and forth with double bond with 2 lone pairs, and this one, by doing so, you have no formal charges. So this is another form. So by having said them all, the structure that you have shown here is now eventually form these 3 double bonds with oxygens, and then that's our final structures. And by doing so, it has no formal charges on oxygen, so that the sulfur has no formal charges. So okay, so how many electron group do you see? Lone pairs? None. How about bonds? There are 3 bonds, right? 3 bonds, including, I'm counting just quote-unquote bonds. Single bond, double bond count as a 1 bond in figuring out the electron group. Electron group, you do not distinguish single bond and double bond in counting the numbers. So the number is 3 here, 3 electron group. That's essentially trigonal planar structure. So it is a fancy name for, all I'm saying is you have a triangle, and then this is a triangle on the plane. That's a trigonal planar, and the sulfur sits in the middle with a double bond with oxygen in the corner. Okay, so that's the structures. The lone pairs looks like this. So therefore, if I just draw the shape itself, it is like this, and that is the same as trigonal planar geometry. Now it's the same as a shape here. This shape is symmetric. Okay, if you're looking at the electron negativity, the electrons are being pulled in 3 different directions, but exactly they cancel out. Although the bond is polar, because shape is symmetric, so therefore it is non-polar molecule. Non-polar molecule. Okay, so therefore SO3 is non-polar molecule because of the symmetry of the shape.